Hello there, and welcome to Calming Cosmos. I'm so glad you've decided to join us tonight. Wherever you are in the world, I hope you're in a peaceful and comfortable place. Perhaps you're lying in bed, wrapped in warmth beneath the covers. Or maybe you're resting on a familiar couch, letting the quiet of the evening settle around you. You might even be outside, beneath a calm sky filled with distant stars, breathing in the cooler night air. However you're settled, I'm truly happy to have you here with us. Before we begin our journey tonight, if you enjoy these calming explorations and would like to hear more, you're welcome to support this channel by giving a like and subscribing. Your support helps this sleepy little channel grow and allows us to keep creating peaceful content like this. And if you're already subscribed, thank you. Your presence and support mean more than you could possibly know. Tonight, we are gently exploring how mountains form. This is not a story of sudden change or dramatic moments. It is a story of patience, of slow movement, of forces that work quietly beneath the surface of the earth, shaping the land over spans of time so vast that they stretch far beyond a single lifetime. Mountains often feel permanent when we look at them. They rise above the landscape with a sense of stability and endurance. From a distance, they appear unmoving, as though they have always been exactly as they are now. Yet mountains are not fixed objects. They are the result of long, ongoing processes that are still unfolding, even as we rest here together. The surface of our planet is not a single, solid shell. It is made up of enormous sections known as tectonic plates. These plates cover the entire Earth, carrying continents, oceans, and everything that lives upon them. Each plate is unimaginably large and incredibly heavy, yet they are always in motion. The movement is subtle, so subtle that we do not feel it beneath our feet. These plates glide slowly over a warmer, softer layer of the Earth below. The motion is measured in millimeters each year, a pace comparable to the slow growth of fingernails. But time, when given enough patience, amplifies even the smallest movement. As these tectonic plates move, they interact with one another in different ways. Some drift apart, some slide past one another, and some move steadily toward each other. It is at these meeting points that mountains begin their quiet formation. When two plates move closer together, they cannot pass through one another. Instead, pressure builds. The Earth's crust responds by thickening, folding, and slowly lifting upward. This process does not crack the land open all at once. It gently reshapes it, layer by layer. Imagine pushing a thick blanket across a smooth surface. As pressure increases, the fabric does not tear. It gathers, it folds, it rises into soft ridges and waves. In much the same way, the Earth's crust responds to slow compression by forming folds that gradually rise into hills and, over immense stretches of time, into mountains. At first, the changes are almost impossible to notice. The land lifts only slightly, a few centimeters here, a few more there. Rivers continue to flow along familiar paths. Forests grow and renew themselves. Animals move through the landscape without any sense of the transformation taking place beneath them. Life carries on, unaware that the ground itself is slowly changing shape. As thousands of years pass, those small changes accumulate. As millions of years unfold, the land rises higher still. Gentle hills become long ridges. Ridges grow taller, steeper, and more defined. What was once nearly flat terrain becomes a vast mountain range stretching across the horizon. This slow upward movement of the Earth's surface is known as uplift. It is one of the most important processes in mountain formation. Uplift does not happen in isolation. It is constantly balanced by another equally quiet force: erosion. As mountains rise, they are shaped by wind, water, ice, and gravity. Rain carries tiny grains of rock downhill. Rivers carve channels that slowly deepen into valleys. Glaciers press and slide across stone, smoothing and reshaping it over time. Gravity gently pulls loosened material downward. Even as the land is being pushed upward from below, it is being softened and sculpted from above. This balance between uplift and erosion gives mountains their distinctive forms. Sharp peaks, rounded summits, deep valleys, and broad plateaus are all expressions of this long interaction. Nothing happens suddenly. Every contour is the result of countless small changes, patiently applied. Some of the world's largest mountain ranges form when entire continents move toward one another. When two continental plates collide, neither easily sinks beneath the other. Instead, the crust thickens and folds, stacking layers of rock on top of each other. Over time, this stacking pushes the surface higher and higher. Other mountains form along the edges of oceans, where one plate slowly slides beneath another. As a plate descends into the earth, heat and pressure cause molten material to rise from below. This material cools and hardens at the surface, adding new layers of rock. Repeated over millions of years, this process builds long chains of mountains. In every case, the rhythm remains the same: slow movement, steady pressure, endless time. Mountains are not expressions of chaos or violence. They are records of persistence. They show us what happens when gentle forces act continuously, without interruption, over unimaginable spans of time. When we look at a mountain, we are looking at time made visible. Each layer of rock tells a story of ancient oceans, shifting land, and slow transformation. Each ridge marks a chapter in the Earth's long history. Mountains also influence the world around them. They guide the movement of rivers and shape weather patterns. They affect how clouds form and where rain falls. They create diverse environments that support unique forms of life. In this way, mountains are not isolated features. They are active participants in the living system of our planet. As we continue together, we will gently explore the different ways mountains form, how they grow and change, and how they eventually return to the earth through the same quiet processes that created them. For now, it is enough to rest in this understanding. The planet beneath you is always moving, not quickly, not urgently, but steadily, patiently, and with remarkable calm. And just like the mountains themselves, there is no need to hurry. We move forward together at the pace of the earth. As we continue together, the pace remains slow and steady. There is no sudden shift, only a gentle deepening of understanding. We are moving further into the quiet mechanics of the earth, where time stretches wide and movement unfolds patiently. Beneath the surface of the planet lies a structure that is both solid and flexible. The outermost layer, known as the crust, forms the foundation of continents and ocean floors. This crust is not especially thick when compared to the size of the Earth as a whole. It rests upon a warmer layer beneath it, one that allows the surface above to move gradually, almost imperceptibly. This slow movement is what allows tectonic plates to travel across the planet. Each tectonic plate is immense. Some carry entire continents. Others support vast ocean basins. Together, they form a moving mosaic that covers the Earth from pole to pole. Though they appear stable from our perspective, they are constantly shifting, guided by heat rising from deep within the planet. The energy driving this motion comes from the Earth's interior. Far below the surface, heat generated by the planet's formation and natural radioactive processes creates slow currents in the underlying layers. These currents do not rush. They circulate gradually, transferring energy upward. Over long periods, this energy is enough to nudge tectonic plates into motion. Where plates move freely, the surface of the Earth remains relatively calm. But where they meet, interact, or resist one another, the landscape begins to change. One of the most important interactions occurs when two plates move toward each other. This movement is known as convergence. It is here, along these converging boundaries, that many of the world's mountain systems begin to form. When convergence happens between two continental plates, neither plate easily sinks downward. Continental crust is relatively light and buoyant compared to other types of crust. As the plates press together, the material at their edges compresses. The crust thickens. Layers of rock begin to fold, bend, and stack upon one another. This thickening causes the surface to rise. The process is slow and continuous. There is no single moment when a mountain suddenly appears. Instead, the land lifts gradually, responding to pressure that is applied evenly over vast regions. The crust behaves less like brittle stone and more like a dense, layered material capable of bending under stress. Over time, these bends become large folds. Some folds stretch for hundreds of kilometers. Others rise higher and steeper as compression continues. The surface of the Earth adjusts itself, redistributing material to accommodate the growing thickness below. This is how some of the tallest mountain ranges on Earth come into existence. Even as the crust rises, gravity remains present, gently pulling everything downward. This balance between upward pressure and downward force shapes the final form of the mountains. The land does not rise endlessly. Instead, it settles into a dynamic equilibrium, rising slowly while erosion works just as patiently to wear it down. In other regions, convergence involves different types of plates. When an oceanic plate meets a continental plate, the interaction unfolds in a different way. Oceanic crust is denser and heavier. As it moves toward a continental plate, it gradually sinks beneath it. This process is known as subduction. As the oceanic plate descends into the Earth, it carries water and minerals with it. Deep below the surface, heat and pressure cause these materials to change. Some of the descending material melts and becomes molten rock. This molten material is lighter than the surrounding rock, so it begins to rise slowly toward the surface. Over time, this rising material cools and solidifies, adding new layers of rock to the edge of the continent. Repeated over millions of years, this process builds long chains of mountains along continental margins. These mountains grow layer by layer. Each addition is small. Each cycle takes thousands of years, yet the accumulation is immense. Entire landscapes are reshaped through this quiet repetition. The surface expression of these processes may include volcanic activity, but even this unfolds over long spans of time. Individual events are brief compared to the overall rhythm of mountain building. The greater story is one of gradual construction, guided by internal heat and slow motion. There are also places where plates slide past one another rather than directly colliding. In these regions, the crust is neither strongly compressed nor pulled apart. Instead, stress builds along long fractures in the Earth's surface. Over time, this stress is released through movement, allowing blocks of crust to shift relative to one another. While this type of movement does not always create towering mountain ranges, it can uplift sections of the land, forming ridges and elevated regions. Even here, the changes occur incrementally. Small adjustments accumulate into noticeable features only when viewed across geological time. Mountain formation is not limited to a single mechanism. It is the result of multiple processes working together, each contributing in its own way. Compression thickens the crust. Subduction adds material. Heat drives movement. Gravity shapes the result. Throughout all of this, time remains the most important ingredient. Millions of years pass without any dramatic interruption. The planet continues its slow motion, indifferent to the brief moments of human observation. Landscapes rise and fall. Oceans advance and retreat. Mountains emerge, evolve, and eventually begin to return to the Earth. As mountains grow, they influence their surroundings more and more. Rising land alters wind patterns, guiding air upward and affecting how clouds form. Increased elevation changes temperature and moisture, creating new environments where different forms of life can thrive. Rivers adjust their paths, carving deeper channels as the land lifts beneath them. These interactions add complexity to the landscape, but they do not accelerate the underlying processes. Everything continues at the same unhurried pace. The rocks within mountains hold records of their formation. Layers that were once flat are now tilted and folded. Materials that formed deep underground are exposed at the surface. Fossils of ancient marine life can sometimes be found high above sea level, reminders that the land has traveled far from its original position. These records are not chaotic. They follow patterns that reflect the forces acting upon them. Compression leaves its mark in folded layers. Heat alters minerals in predictable ways. Pressure transforms rock gradually, changing its texture and strength. By studying these patterns, scientists are able to reconstruct the long histories of mountain ranges. They trace the movements of plates, the timing of uplift, and the balance between construction and erosion. The story that emerges is one of consistency rather than sudden change. Mountains do not challenge the laws of nature. They are shaped by them. As we move deeper into this exploration, it becomes clear that mountain formation is not a single event, but a continuous process. Even the most ancient ranges are still changing today. Some continue to rise slowly. Others are being worn down, their material carried away grain by grain. Yet whether rising or eroding, the pace remains calm. There is something grounding in this knowledge. The earth does not hurry. It responds to forces with patience and balance. Change happens not through urgency, but through persistence. As we continue onward, we will explore how different mountain types reflect different processes and how the Earth's surface records its own long memory. For now, it is enough to rest in the understanding that beneath the stillness we perceive, the planet is quietly shaping itself, always moving, always adjusting, always in balance. As we move gently onward, the landscape begins to reveal more detail. The slow processes beneath the Earth's surface express themselves in different ways, creating mountains that vary in shape, structure, and character. These differences are not random. Each type of mountain reflects the conditions under which it formed and the forces that shaped it over time. Some mountains rise through the folding of the Earth's crust. These are known as fold mountains. They form when layers of rock are compressed and pushed together, much like fabric gathering under steady pressure. Instead of breaking, the rock bends. Over immense spans of time, these bends grow larger and more pronounced, lifting the land upward. Fold mountains tend to form in long, sweeping ranges. Their slopes are often broad, with ridges that stretch across vast distances. The rock layers within them remain visible, stacked and curved, preserving a record of the forces that shaped them. These layers may once have rested beneath ancient seas, only to be slowly raised high above their original position. The growth of fold mountains is gradual. Pressure continues long after the first uplift begins. As compression persists, the crust thickens further, allowing the range to rise higher. At the same time, erosion quietly reshapes the surface, smoothing sharp edges and carving valleys between ridges. The result is a balance between uplift from below and gentle sculpting from above. Other mountains form through faulting. In these cases, the Earth's crust responds to stress by breaking rather than folding. Large blocks of crust shift relative to one another along fractures known as faults. When one block rises above its neighbor, a fault block mountain is created. Fault block mountains often have steep sides and flatter tops. Their shape reflects the way the crust moved, with one section lifting while another remained lower. The movement itself may be slow and incremental, occurring in small adjustments over long periods. Each shift contributes slightly to the overall elevation of the range. Even here, patience defines the process. A single movement may raise the land only a small amount, but repeated many times over millions of years, these changes accumulate. Valleys deepen, peaks become more distinct. The landscape gradually takes on its characteristic form. Volcanic mountains follow a different path. They are built not through compression or faulting, but through the steady accumulation of material from below. Molten rock rises through the crust and reaches the surface, where it cools and hardens. Each addition adds a new layer to the growing structure. Volcanic mountains grow incrementally. One layer forms, then another, and then another. Over time, these layers stack upon each other, building height and mass. The pace is slow when viewed across geological time, even though individual events may appear brief in comparison. The shape of a volcanic mountain depends on the nature of the material being added. Some grow with broad, gentle slopes, spreading outward as material flows easily across the surface. Others rise more steeply, built from layers that accumulate closer to the source. In all cases, the underlying principle remains the same. Growth occurs through repetition and accumulation. There are also mountains formed through uplift without significant folding or faulting. In these cases, large regions of the crust rise together, creating plateaus or broad elevated areas. Over time, erosion cuts into these uplifted surfaces, carving valleys and leaving behind isolated peaks and ridges. These mountains may not appear dramatic at first glance. Their slopes are often gentle, their elevations gradual. Yet they, too, represent the outcome of long-term forces acting steadily beneath the surface. Their quiet presence reflects the Earth's ability to reshape itself without spectacle. While these categories help us understand mountain formation, the reality is often more complex. Many mountain ranges are shaped by multiple processes acting together. Folding may occur alongside faulting. Volcanic activity may add material, even as compression lifts the land. The final landscape reflects the combined influence of these forces over time. As mountains rise, the rocks within them respond to changing conditions. Pressure increases, temperature shifts. Over long periods, these conditions alter the structure of the rock itself. Minerals realign, new textures form. Solid stone becomes capable of bending rather than breaking. This transformation is known as metamorphism. It occurs quietly, deep within the earth, as rock adjusts to its environment. Metamorphism does not create mountains on its own, but it plays an important role in shaping their internal structure. Metamorphic rocks often form the core of large mountain ranges. These rocks bear the imprint of the immense pressures involved in mountain building. Their presence tells a story of depth and time, revealing how far material has traveled from its original position. As erosion continues to wear away the surface, these deep rocks may eventually be exposed. What was once buried kilometers below the surface becomes visible, offering a glimpse into the hidden processes that shape the land. In this way, mountains slowly reveal their own history. The interaction between uplift and erosion never truly ends. As long as forces beneath the earth continue to act, mountains may continue to rise. As long as wind, water, and gravity persist, they will continue to be shaped and softened. Some mountain ranges are still actively growing today. Others have reached a stage where erosion outpaces uplift. Over time, even the tallest peaks may be reduced to rolling hills, their material carried away grain by grain. Yet, the process remains consistent, governed by the same principles that first raised them. Mountains also influence the rhythm of the planet beyond geology. As they rise, they affect climate patterns. Air moving across the land is guided upward by elevated terrain, cooling as it rises. This cooling leads to cloud formation and precipitation on one side of a range, while creating drier conditions on the other. These patterns shape ecosystems, determining where forests grow, where grasslands spread, and where deserts form. Rivers begin in high elevations, fed by rain and melting snow, carrying water and nutrients far from their source. In this way, mountains serve as quiet architects of the broader landscape. Life adapts to these changes slowly, just as the land does. Plants and animals adjust to elevation, temperature, and moisture. Over time, distinct communities form, each shaped by the conditions created by rising terrain. The presence of mountains adds diversity and complexity to the living world. Yet even as mountains shape life, they are shaped in return. Vegetation stabilizes slopes. Roots hold soil in place. Organic material contributes to the gradual breakdown of rock. Life becomes part of the ongoing process, participating in the slow transformation of the land. There is a calm symmetry in this relationship. The earth shapes mountains. Mountains shape environments. Environments support life. And life, in subtle ways, influences the land again. As we continue this exploration, the picture becomes clearer. Mountains are not isolated features. They are part of a continuous system, shaped by deep forces and surface processes working together over time. Nothing here is hurried. Nothing is forced. Each change unfolds naturally, guided by balance and persistence. In the next part of our journey, we will look more closely at how time itself becomes visible in mountains, and how layers of rock preserve memories of ancient worlds. For now, it is enough to rest in the quiet understanding that every mountain tells a story written slowly, patiently, and without urgency. As we move gently forward, the focus shifts from how mountains rise to how they endure. Once the land has lifted, once ridges and peaks have taken shape, a long and quiet partnership begins between the solid earth and the forces acting upon its surface. This partnership is neither hurried nor harsh. It unfolds gradually, shaping mountains into the forms we recognize today. One of the most constant influences on mountains is weathering. Weathering does not move rock from one place to another. Instead, it works patiently to break solid stone into smaller pieces. Temperature changes cause rock to expand and contract. Water seeps into tiny cracks and over time widens them. Ice forms, melts, and forms again, gently prying rock apart, grain by grain. This process happens everywhere, but in mountains, it becomes especially noticeable. Higher elevations experience stronger temperature variations. Winds move freely across exposed ridges. Snow and ice linger for long periods, quietly working on the surface beneath them. None of this happens quickly. Each small change builds upon the last. As rock breaks down, erosion begins to take over. Erosion is the slow transport of material away from its original location. Gravity pulls loosened fragments downhill. Water carries sediment along streams and rivers. Glaciers, thick and heavy, move almost imperceptibly, scraping and shaping the land beneath them. Erosion does not act against mountain formation. Instead, it completes it. Without erosion, mountains would rise unevenly and without character. Valleys would not deepen, peaks would not sharpen. The familiar profiles of mountain ranges exist because erosion has been at work for as long as uplift itself. Rivers play a particularly important role in shaping mountains. As land rises, rivers respond by cutting downward, maintaining their path toward lower elevations. Over time, this cutting forms deep valleys that slice through rising terrain. These valleys reveal layers of rock that were once hidden far below the surface. The presence of a river is a sign of balance. The land lifts. The river adjusts. Neither dominates completely. Together, they shape a landscape that evolves slowly, always responding to change without abrupt shifts. In colder regions, glaciers become powerful sculptors. Though they move slowly, their mass gives them remarkable influence. As glaciers advance and retreat, they carve broad valleys with smooth, curved walls. They polish rock surfaces and transport vast amounts of material over long distances. Glacial landscapes have a calm simplicity to them. Wide valleys, gentle slopes, rounded peaks. These forms reflect the steady motion of ice over time, shaping the land with consistency rather than force. Even after glaciers retreat, their influence remains. Lakes fill carved basins. Rivers follow newly formed channels. The land carries the imprint of ice long after it has melted away. As erosion continues, mountains gradually lose height. Peaks become lower. Slopes become smoother. Over millions of years, a towering range may transform into rolling hills. Given enough time, even these hills may wear down further, blending into the surrounding landscape. This process does not mean mountains disappear entirely. Instead, their material is redistributed. Sediment carried away by rivers settles in distant plains, deltas, and ocean basins. In this way, mountains contribute to the formation of new land elsewhere, continuing the cycle of change. The balance between uplift and erosion determines the lifespan of a mountain range. In some regions, uplift continues faster than erosion can remove material. Mountains remain tall and rugged. In others, uplift slows or stops, allowing erosion to gradually reduce elevation. Neither outcome is sudden. Both unfold over immense spans of time. The Earth adjusts itself continuously, maintaining balance through slow and steady change. As mountains evolve, they also influence the atmosphere above them. High elevations alter wind patterns, forcing air upward. As air rises, it cools, releasing moisture as rain or snow. This process creates distinct climates on either side of a range, shaping vegetation and water availability. These climatic effects are not separate from mountain formation. They are part of the same system. The shape of the land influences the movement of air and water, which in turn affects erosion rates. Wetter regions experience more rapid surface change. Drier regions preserve sharper features for longer periods. Vegetation plays a quiet role in this process as well. Plants take root in cracks and soil pockets, stabilizing slopes and reducing erosion. Roots hold material in place. Organic matter contributes to soil formation, which further slows the movement of sediment. Over time, entire ecosystems become intertwined with the mountains that support them. Forests grow on slopes. Meadows spread across high plateaus. Wildlife adapts to elevation and climate. Life becomes part of the mountain's ongoing transformation. Even as mountains wear down, the forces beneath the earth may continue to act. In some regions, uplift resumes after long pauses. New pressure builds. The land rises again. Ancient ranges may experience renewed growth, their old foundations supporting new elevations. This cycle of rise, erosion, and renewal reflects the Earth's long memory. Nothing is truly finished. Landscapes are never complete. They are always responding to changing conditions, guided by the same underlying principles. The rocks within mountains record these changes in quiet detail. Layers reveal periods of rapid erosion or relative calm. Mineral composition reflects changes in pressure and temperature. Fossils embedded in rock offer glimpses into environments that existed long before the mountains reached their current height. By reading these records, scientists reconstruct the slow story of mountain evolution. They trace how ranges grew, how they were shaped, and how they changed over time. The patterns repeat across the planet, demonstrating the consistency of natural processes. What emerges from this understanding is a sense of continuity. Mountains are not exceptions to the Earth's behavior. They are expressions of it. They show how steady forces, acting patiently, can create complexity and beauty without urgency. As we rest in this knowledge, it becomes easier to see mountains not as static objects, but as moments within a long, unfolding process. Their current form is temporary, just as all forms are. Yet their presence carries meaning, connecting deep time with the surface we see today. As we move onward, we will explore how mountains interact with the deeper layers of the Earth, and how the planet maintains balance across immense spans of time. For now, it is enough to remain with this calm rhythm, where nothing is rushed and every change arrives exactly when it needs to. As the journey carries us onward, attention gently turns beneath the visible surface of mountains into the deeper layers that support them. What we see rising into the sky is only a small part of a much larger structure. Most of a mountain exists below the surface, anchored deep within the earth, supported by forces that act quietly and continuously. The Earth's crust behaves in a way that may feel surprising. Though it appears rigid and unyielding, over long periods it responds to weight and pressure by slowly adjusting. This behavior allows mountains to be supported from below, much like an iceberg floating in water, with most of its mass hidden beneath the surface. This principle is known as isostasy. It describes how the crust rises or sinks depending on the weight it carries. When a region of the crust becomes thicker and heavier, as it does during mountain formation, it extends downward into the softer layer beneath it. This deep root helps support the elevated land above. As mountains grow taller, their roots grow deeper. The crust responds by redistributing material, maintaining balance over time. This process does not happen suddenly. It unfolds gradually, adjusting continuously as conditions change. When erosion removes material from the surface of a mountain, the balance shifts again. With less weight pressing down, the crust responds by rising slightly. This uplift is subtle, but over millions of years, it can be significant. In this way, erosion does not simply wear mountains away. It can also contribute to their continued elevation. This interaction creates a quiet feedback loop. Mountains rise, erosion removes material, the crust adjusts, the surface rises again, just enough to maintain balance. The result is a long-lasting landscape that changes slowly, always responding to the forces acting upon it. Deep beneath mountain ranges, temperatures and pressures are far higher than at the surface. Here, rock behaves differently. Instead of cracking or breaking, it flows slowly, adjusting its shape over time. This flow allows stress to be distributed, preventing sudden failure and supporting gradual uplift. The rocks at these depths carry the imprint of immense pressure. Minerals align themselves in response to stress. New textures form as atoms rearrange. These changes occur silently, hidden far below the surface, yet they play a crucial role in mountain stability. As uplift continues, material from deep within the crust may eventually be brought closer to the surface. Over time, erosion removes overlying layers, exposing rocks that once formed under great pressure. These rocks tell a story of depth, movement, and time, revealing the inner workings of mountain formation. Mountains also influence the flow of heat within the earth. Thickened crust acts as insulation, trapping heat below. This trapped heat can affect the behavior of surrounding rock, allowing it to remain flexible for longer periods. This flexibility supports continued movement and adjustment, sustaining mountain growth over extended timescales. In regions where uplift has slowed or stopped, cooling gradually stiffens the crust. Movement becomes less pronounced. The landscape enters a new phase of its life, shaped primarily by surface processes rather than internal forces. Even then, the transition is smooth and unhurried. The deep structure of mountains helps explain why some ranges persist for so long. Their roots anchor them, providing stability even as erosion works tirelessly at the surface. This balance allows mountains to endure for tens of millions of years, maintaining their presence across vast spans of time. Not all mountains are supported equally. Differences in crustal thickness, composition, and temperature lead to variation in how ranges develop and evolve. Some rise quickly and remain high. Others grow slowly and wear down more rapidly. Each range reflects the conditions under which it formed. As we consider these deep processes, it becomes clear that mountains are not isolated features. They are part of the Earth's larger system of balance and adjustment. The same principles that support mountain ranges also govern the elevation of continents and the depth of ocean basins. The planet continually redistributes material, responding to changes in weight and pressure. Ice sheets form and melt. Sediment accumulates and erodes. Mountains rise and wear away. Each change prompts a response, maintaining equilibrium over time. This balance extends to the way mountains influence earthquakes and slow movement along faults. Stress accumulates gradually in the crust as forces continue to act. In most cases, this stress is released slowly, allowing the Earth to adjust without dramatic disruption. Even where movement occurs, it reflects the ongoing effort to maintain balance. The quiet nature of these processes reinforces an important truth. The Earth does not rely on sudden change to reshape itself. It depends on patience, consistency, and time. Mountains are the visible outcome of this approach, rising steadily as forces work quietly below. As erosion continues to shape the surface, valleys deepen and peaks soften. The deep roots respond by rising incrementally, maintaining elevation. This slow compensation keeps the landscape dynamic, never static, yet never rushed. In some regions, the balance eventually shifts. Internal forces weaken, uplift slows, erosion gains the upper hand. Mountains begin a long descent, their material carried away to form new landscapes elsewhere. Even then, the process remains gentle, unfolding over spans of time too large to measure easily. What remains constant is the rhythm. Rise, adjust, wear down, redistribute. Each phase flows naturally into the next, guided by the same fundamental principles. Understanding this deep structure invites a different way of seeing mountains. Rather than solid monuments, they become expressions of balance. Rather than permanent features, they become moments within a larger cycle. Their height reflects not only the forces that build them, but also the quiet adjustments that continue beneath them. As we move further along this path, we will begin to explore how mountains record the passage of time, preserving clues to ancient climates and environments. For now, it is enough to rest in the knowledge that beneath every mountain lies a deep foundation, patiently supporting the land above. The surface may change, the form may soften, but the underlying balance remains, always steady, always present, always quietly at work. The narrative settles into a deeper rhythm. The focus widens once again. We are no longer looking only at individual mountains or isolated ranges. Instead, attention drifts across entire regions where mountain systems interact with one another and with the broader movements of the planet itself. Across the surface of the Earth, mountains rarely exist alone. They often form long chains, sweeping across continents in arcs and curves that mirror the motion of tectonic plates beneath them. These vast systems reflect not just local forces, but large-scale patterns of movement that shape the planet as a whole. When plates converge over extended regions, the effects are not confined to a single ridge or peak. Pressure spreads outward. The crust thickens across wide areas. Multiple ranges may rise side by side, connected by shared foundations deep below the surface. Over time, these connected ranges form mountain belts that stretch for thousands of kilometers. Within these belts, uplift does not occur evenly. Some areas rise higher, others remain lower. This variation creates complex landscapes of peaks, plateaus, and valleys, each responding slightly differently to the forces at work beneath them. The differences are subtle at first, but they become more pronounced as time unfolds. Gradually, a sense of scale emerges. Mountains are no longer just local features. They become continental structures, influencing regions far beyond their immediate surroundings. Their height affects atmospheric circulation. Their presence redirects rivers. Their mass alters the balance of the crust beneath them. As these systems grow, the Earth continues to adjust. Material deep within the planet flows slowly toward areas of thickened crust, redistributing pressure. This movement supports continued uplift, even as erosion works steadily at the surface. The landscape responds as a whole, maintaining balance across vast distances. Over millions of years, these adjustments create distinct phases in a mountain system's life. There are periods of active growth when uplift dominates. There are quieter phases when erosion and internal adjustment take the lead. Each phase blends smoothly into the next, without clear boundaries. In some regions, ancient mountain belts tell stories of multiple cycles. Ranges that once rose high were worn down nearly flat, only to be uplifted again later. Their rocks record these repeated transformations, preserving layers from different eras within the same structure. This layering is one of the most remarkable features of mountain systems. Rocks formed in shallow seas may sit alongside materials created deep within the crust. Each layer represents a different environment, a different moment in the Earth's long history, brought together through slow movement and time. As mountains evolve, they influence the distribution of stress across the crust. Pressure does not remain fixed in one place. It migrates, shifting toward regions of resistance or weakness. This movement guides where new uplift may occur and where existing ranges may begin to relax. The Earth responds to imbalance, not with urgency but with redistribution. When one region becomes too heavy or too thick, material flows away. When another region thins or cools, it may sink slightly, creating space elsewhere. The result is a planet that continually reshapes itself without sudden change. At the surface, these deep adjustments manifest as gentle shifts in elevation. Plateaus may rise or sink. Valleys may deepen or broaden. Over long spans of time, even small changes accumulate into meaningful transformations. Mountain systems also play a role in separating geological regions. As ranges rise, they act as boundaries, dividing landscapes into distinct zones. On one side, conditions may favor dense forests and abundant rainfall. On the other, drier environments may emerge, shaped by altered airflow and reduced moisture. These divisions influence not only climate, but also the movement of life. Species adapt to elevation, temperature, and terrain. Over time, mountain ranges contribute to the development of unique ecosystems, each shaped by the slow evolution of the land itself. As erosion continues, material removed from mountains does not vanish. It is transported across the landscape, settling in basins, plains, and oceans. These deposits build new layers of rock, which may one day be uplifted themselves, continuing the cycle. In this way, mountains are both sources and destinations. They rise from recycled material, and they provide material for future landscapes. Nothing is wasted. Everything is reused, reshaped, and repositioned through time. The pace remains unhurried. Even when viewed across entire continents, the movement is measured in small increments, millimeter by millimeter, grain by grain, layer by layer. The Earth does not hurry to complete its work. As mountain systems age, their internal heat slowly dissipates. The crust cools. Movement becomes less fluid. Eventually, uplift slows, and erosion begins to dominate. Peaks lower, slopes smooth, valleys widen. The range enters a quieter stage of its existence. Yet even in this stage, change continues. Rivers adjust their courses. Sediment accumulates downstream. The landscape evolves toward new forms, guided by the same principles that shaped it before. What emerges from this long view is a sense of continuity. Mountain systems are not separate episodes in Earth's history. They are chapters within a single, ongoing story. Each range reflects a particular balance of forces, shaped by its location, its materials, and its time. As we move gently forward, the emphasis begins to shift once more. We start to notice how mountains serve as archives, preserving evidence of ancient worlds within their rocks. Layers become records, structures become memories, the land itself becomes a quiet historian. For now, it is enough to remain with this broader perspective, to see mountains not only as individual forms, but as interconnected systems woven into the fabric of the planet, always responding, always adjusting, always unfolding at its own pace. As the narrative settles into an even broader view, attention drifts gently into the layers themselves. Mountains are not only shapes rising into the sky, they are archives. Within their rock layers lies a quiet record of environments that existed long before the mountains took their present form. Every layer of rock tells a story. Some layers began as sediments settling at the bottom of ancient oceans. Others formed from volcanic material cooling at the surface. Still others were shaped deep underground, transformed by heat and pressure into new structures. Over time, these layers were lifted, folded, tilted, and exposed, becoming part of a mountain's visible form. The order of these layers is rarely accidental. Lower layers often represent older environments, while higher layers reflect more recent conditions. As mountains rise and erosion removes material from above, deeper layers gradually come into view. In this way, mountains slowly reveal their own past. These layers can contain remarkable details. Fine grains of sand may indicate slow-moving water. Rounded pebbles suggest ancient rivers. Fossils preserved within sedimentary rock speak of life that once thrived in warm seas or coastal plains. When such fossils are found high within mountains, they offer clear evidence of long-term uplift. The presence of marine fossils far above sea level is not unusual in mountain ranges. It is a quiet reminder that the land has traveled a great distance from where it began. What was once ocean floor has been carried upward through the patient motion of tectonic plates. As pressure increases during mountain building, rock layers do not remain unchanged. They respond by bending, stretching, and compressing. In some cases, layers fold into graceful arcs. In others, they fracture and shift. These deformations preserve the direction and intensity of the forces that acted upon them. Geologists study these patterns to understand how mountains formed. The angle of a fold, the thickness of a layer, and the alignment of minerals all provide clues. Each detail adds to a larger picture, revealing the sequence of events that shape the range. Deep within mountains, where pressure and temperature are highest, rocks may undergo profound transformation. Minerals recrystallize, new textures emerge. Original features are altered, but not erased. The rock carries both its original identity and the imprint of the conditions it experienced. This transformation creates metamorphic rocks, which often form the core of large mountain systems. These rocks are durable, capable of withstanding erosion longer than surrounding material. As softer layers are worn away, metamorphic cores may stand out, forming prominent ridges and peaks. The exposure of these deep rocks at the surface takes immense time. Kilometer after kilometer of overlying material must be removed through erosion. Each grain of sediment carried away contributes to this slow unveiling. What emerges is a cross-section of the Earth's interior, made visible through patience. As mountains evolve, their internal structure becomes more complex. Layers stack, fold, and interlock. Faults cut through existing formations. New material may be added from below. The result is a dynamic system that records multiple phases of activity within a single range. These records are not always simple to interpret. Layers may be overturned, placing older material above younger layers. Faults may repeat sections of rock, creating patterns that require careful study. Yet even this complexity reflects consistent processes acting over time. Beyond structure, mountains also preserve evidence of past climates. Certain rock types form only under specific conditions. Glacial deposits indicate periods of cold. Evaporite minerals suggest arid environments. Soil layers reveal long intervals of stability at the surface. By reading these clues, scientists reconstruct ancient landscapes. They identify when glaciers advanced and retreated. They trace shifts in rainfall and temperature. Mountains become reference points for understanding how the planet's climate has changed over millions of years. These climatic shifts often interact with mountain formation itself. Rising terrain can alter regional climate, which in turn affects erosion rates. Increased rainfall accelerates surface change. Cooler temperatures allow ice to persist, shaping valleys and peaks. The land and atmosphere influence each other continuously. This interaction adds another layer to the mountain's story. Not only do mountains reflect deep earth processes, but they also record surface conditions shaped by their own presence. The landscape and climate evolve together, each responding to changes in the other. Over time, these interactions contribute to the diversity of mountain forms around the world. Some ranges are sharp and rugged, shaped by recent uplift and active erosion. Others are rounded and subdued, reflecting long periods of stability and wear. Each form represents a particular balance of forces. As we consider these differences, it becomes clear that no mountain is truly isolated in time. Every range carries evidence of earlier phases, some reaching back hundreds of millions of years. Even young mountains may contain ancient rocks, lifted from deep within the crust. This deep history invites a different sense of perspective. Mountains are not simply features of the present landscape. They are connections to distant worlds, preserved through layers of stone. Each ridge is a boundary between what was and what is. As erosion continues, these records are slowly revealed. Valleys cut deeper, slopes retreat, new exposures appear. The story becomes clearer. not through sudden discovery, but through steady change. The pace remains calm. Mountains do not reveal their secrets all at once. They allow understanding to grow gradually, mirroring the processes that formed them. Knowledge accumulates layer by layer, much like the rocks themselves. As we move gently onward, attention begins to shift once more. From the records held within mountains, we turn toward the role they play in shaping the surface of the planet over time. We begin to notice how their presence influences the flow of water, the movement of sediment, and the arrangement of entire landscapes. For now, it is enough to rest with this idea that within every mountain lies a quiet archive, a memory of ancient seas, shifting land, changing climates, and persistent motion, all preserved through patience, balance, and time. As the flow carries us onward, attention settles gently on how mountains guide the movement of water across the planet. Once land rises, it becomes a quiet organizer of flow, shaping the paths that rivers follow and influencing how landscapes evolve far beyond the mountains themselves. Water is always responding to gravity. It seeks the lowest path, moving steadily downhill. When mountains rise, they change that path. High ground becomes a source. Rain and melting snow collect at elevation, then begin their slow descent, carving routes that may persist for millions of years. These routes become rivers. At first, the channels are small. Thin streams gather on slopes, joining one another as they move downward. Over time, these streams merge into larger flows, cutting into the rising land. The cutting is not aggressive. It is persistent. Each season adds a little depth. Each year removes a little more material. As mountains continue to rise, rivers respond by cutting deeper. This process maintains a balance. The land lifts. The river lowers its bed. Neither overwhelms the other. Together, they shape valleys that reflect both uplift and erosion. Some valleys are narrow and steep, formed where uplift is rapid and erosion keeps pace by cutting downward. Others are wide and gentle, shaped where uplift slows and erosion spreads laterally. The form of a valley reveals the rhythm of the forces that created it. Over long periods, river systems extend their influence far beyond the mountains. Sediment carried downstream settles in plains, floodplains, and deltas. Material once part of a high peak may eventually become part of distant lowlands or ocean floors. Mountains thus contribute to the formation of entirely new landscapes. This transfer of material is slow and continuous. Each grain of sand follows its own quiet journey, guided by water, gravity, and time. There is no single moment when the mountain loses its substance. Instead, it is redistributed gradually, becoming part of something new. In colder regions, water takes on a different role. Snow accumulates at high elevations, compacting into ice. Over time, this ice begins to move, flowing slowly downhill under its own weight. Glaciers form, becoming powerful agents of change. Glaciers reshape mountains in distinctive ways. Their movement smooths surfaces and widens valleys. Instead of cutting narrow channels like rivers, glaciers carve broad, curved forms. The valleys they leave behind are spacious and open, reflecting the steady passage of ice. As glaciers advance and retreat, they transport large amounts of material. Rocks embedded in the ice scrape against the ground, polishing and reshaping it. When the ice melts, this material is left behind, forming ridges, deposits, and basins that persist long after the glacier is gone. These glacial features add another layer to the mountain's story. They mark periods of colder climate, times when ice dominated the landscape. Their presence shows how climate and mountain evolution are closely connected, each influencing the other over long spans of time. Beyond shaping valleys, mountains influence how water is distributed across entire regions. Elevated terrain forces air to rise, cooling it and causing moisture to condense. This process leads to increased rainfall or snowfall on one side of a range, while creating drier conditions on the other. These patterns shape ecosystems. Forests may thrive on windward slopes, where moisture is abundant. Grasslands or deserts may form in the rain shadow beyond the peaks. The presence of mountains thus determines where water is available, guiding the distribution of life. Rivers born in mountains often become lifelines for regions far downstream. They carry fresh water, nutrients, and sediment across vast distances. Communities, ecosystems, and entire civilizations have depended on these flows, shaped indirectly by the slow rise of distant mountains. Yet even as mountains provide water, they also respond to it. Increased rainfall accelerates erosion, wearing down slopes more quickly. Reduced moisture preserves sharper features. The balance between uplift and erosion shifts in response to climate, altering the pace of change. This interaction creates feedback loops. Rising mountains change climate. Climate affects erosion. Erosion influences elevation. The system adjusts continuously, always seeking balance, never reaching a final state. Over geological time, river systems themselves evolve. Channels shift, valleys widen, drainage patterns reorganize. A river that once flowed in one direction may be captured by another, redirected by subtle changes in elevation. These rearrangements are slow and incremental, yet their effects can be profound. The traces of these changes remain etched into the landscape. Abandoned valleys, curved ridges, and isolated plateaus reveal earlier paths of water flow. By studying these features, scientists reconstruct how mountain regions have changed over time. Mountains also influence groundwater. Water seeps into cracks and pores in rock, moving slowly beneath the surface. This hidden flow contributes to springs and aquifers, storing water over long periods. The structure of the mountain determines how water moves and where it emerges. In this way, mountains act as reservoirs as well as sources. They collect, store, and release water gradually, smoothing extremes and supporting life across seasons. This quiet service continues as long as the mountains remain elevated. As erosion proceeds, the shape of the land evolves, but the underlying patterns persist. Water continues to follow gravity. Ice continues to flow where conditions allow. The Earth's surface responds to these forces with patience. From a long perspective, the movement of water reveals the ongoing dialogue between surface and depth. Uplift creates height. Height creates flow. Flow reshapes the land. The cycle repeats, guided by the same simple principles. This understanding brings a sense of coherence. Mountains, rivers, glaciers, and plains are not separate elements. They are parts of a single system, connected through slow motion and shared balance. As we rest with this idea, the emphasis begins to shift once more. From the movement of water, attention turns toward the passage of time itself and how mountains serve as markers of Earth's long rhythms. For now, it is enough to remain with the gentle flow, to recognize that every river begins with elevation, and every valley reflects both movement and patience. The land changes not through urgency, but through consistency, always flowing, always adjusting, always finding its way. As the rhythm carries us forward, the sense of time begins to stretch even wider. Mountains invite us to think not in years or generations, but in spans so large they soften the edges of cause and effect. In this slower frame, mountains become markers of the Earth's long cycles, rising and changing as part of patterns that repeat across deep time. Every mountain range exists within a broader tectonic setting. Plates come together, pull apart, or slide alongside one another, and over millions of years, these motions reorganize the surface of the planet. Oceans open and close, continents drift, collide, and separate. Mountains rise during some phases of this movement and fade during others. This long cycle is sometimes described as a slow breathing of the earth. Crust thickens and lifts. Later, it thins and settles. What appears permanent at one moment becomes temporary when viewed across hundreds of millions of years. Mountains, for all their size, are participants in this ongoing motion. As continents move, mountain belts may form far from where they began. A range that rose at the edge of one landmass may later find itself deep within a continent, carried there by plate motion. Over time, erosion may reduce its height, leaving behind only subtle ridges or hardened roots buried beneath the surface. These ancient remnants are known as old mountain cores. They often lie hidden beneath plains or forests, their presence revealed only through careful study. Though they no longer dominate the skyline, they continue to influence the structure of the crust and the flow of heat below. In some cases, these ancient foundations become the starting point for new mountain building. When tectonic conditions change, pressure may return to regions that were once active long ago. The old roots provide strength, guiding where uplift occurs. Mountains rise again, shaped by both past and present forces. This recycling of structure illustrates how the earth conserves its material. Nothing is entirely erased. Rock that once formed a peak may later become part of a deep foundation. Material worn away from mountains settles elsewhere, only to be uplifted again in another cycle. Time weaves these processes together. As mountains rise and fall, they influence the planet's climate on long timescales. Elevated terrain affects atmospheric circulation, which in turn influences global temperature patterns. Large mountain systems can alter how heat is distributed across the Earth, contributing to periods of cooling or warming. Increased elevation can enhance weathering, drawing certain elements out of the atmosphere and into rock and sediment. Over millions of years, this process can affect the composition of the air itself. In this way, mountains participate quietly in regulating the planet's climate. The connection between mountains and climate is subtle but persistent. As ranges rise, they may contribute to cooler conditions. As they erode and lower, different patterns may emerge. The Earth adjusts continuously, balancing internal and external influences. Life responds to these shifts slowly. Species adapt to new environments created by changing elevation and climate. Over time, mountains contribute to the diversification of life by creating isolated habitats and varied conditions. Valleys, slopes, and plateaus each offer different opportunities for adaptation. Yet, even as life changes, the pace remains unhurried. Evolution unfolds alongside geological processes, both operating on timescales that encourage patience rather than urgency. Mountains provide a stable backdrop against which gradual change can occur. From a broader perspective, mountains remind us that time itself is layered. Short-term events pass quickly, leaving little trace. Long-term processes leave deeper marks, shaping landscapes and ecosystems in enduring ways. Mountains are records of these longer rhythms. When we step back far enough, individual peaks lose their sharpness. Entire ranges become gentle curves in the Earth's surface. The planet appears smoother, more unified. Differences that once felt dramatic blend into a continuous form shaped by motion and balance. In this view, mountains are not obstacles or boundaries. They are expressions of flow. They show where energy has accumulated and where it is being redistributed. They mark places where the Earth has adjusted itself, responding to pressure with elevation. As erosion continues its quiet work, mountains slowly surrender their height. Material moves outward and downward, spreading across lower regions. Over immense spans of time, the distinction between mountain and plain softens. And yet, the story does not end there. New forces arise. Plates shift direction. Pressure builds once more. In different places, under different conditions, mountains begin to form again. The cycle continues, guided by the same principles that have always shaped the planet. This continuity offers a sense of calm. There is no final form toward which the Earth is moving. There is only ongoing adjustment, an endless process of change that unfolds without haste. As we move gently toward the final part of this journey, attention begins to turn inward as well as outward. The long view of mountain formation invites reflection, not just on the Earth, but on our place within its rhythms. For now, it is enough to remain with this expansive sense of time, to allow the scale of these processes to quiet the mind. Mountains rise and fall over spans so long that they dwarf individual concerns, offering perspective through their persistence. Always changing, always balanced, always part of a larger flow. As the journey moves into its final phase, everything begins to slow just a little more. The details soften, and the focus shifts from processes and structures toward meaning and connection. Mountains, shaped by time and balance, invite a quieter kind of understanding. When we look at a mountain, we are not only seeing rock and elevation, we are seeing the outcome of countless small adjustments, layered one upon another. Pressure applied patiently, material redistributed carefully, change occurring without urgency. Mountains are reminders that stability does not come from stillness, but from continuous, measured motion. The same forces that raise mountains also work to return them to the earth. Wind, water, ice, and gravity never stop. They do not rush their task. They simply continue, day after day, year after year. In doing so, they remind us that nothing on the planet is separate from the passage of time. As mountains erode, their material travels outward. Sediment becomes soil. Soil supports forests, grasslands, and fields. Minerals carried by rivers nourish ecosystems far from the original peaks. In this way, mountains give of themselves, extending their influence across landscapes and generations. What was once solid stone becomes part of living systems. Trees take root in mineral-rich ground. Rivers carry nutrients downstream. Life flourishes in places shaped indirectly by the slow rise of distant ranges. Mountains, though seemingly remote, participate in cycles that support life everywhere. Even after mountains lose their height, their presence lingers. Hardened roots remain buried deep within the crust. These foundations continue to influence how the land responds to future forces. When conditions change, they may guide new uplift, shaping where the next mountains will rise. Nothing is wasted. Nothing is forgotten. The earth remembers its past through structure and form. Each cycle builds upon the last, creating continuity rather than repetition. Mountains are chapters in this ongoing story, each one shaped by its time and circumstances. As we reflect on these ideas, it becomes easier to sense the calm inherent in geological processes. There is no competition between forces, no struggle for dominance. Instead, there is balance. Pressure is met with adjustment. Change is met with response. Over time, the system remains whole. This balance can feel reassuring. The planet has been shaping itself for billions of years, guided by the same principles we see today. Mountains have risen and fallen countless times, yet the Earth continues, adapting smoothly to each transformation. In this long view, human concerns become quieter. Our moments are brief compared to the rhythms of the planet. Yet we are not separate from them. We live on land shaped by ancient motion. We drink water guided by elevation. We breathe air influenced by distant ranges. We are participants in these cycles, even if we rarely notice them. Mountains offer perspective. They show how patience leads to form, how persistence creates beauty, and how balance sustains complexity. Their presence encourages a gentler way of thinking, one that allows time to unfold without resistance. As this journey draws to a close, there is no need to hold on to every detail. The processes we have explored are not meant to be memorized. They are meant to be felt as patterns, rhythms, and quiet truths. The earth moves slowly. Change arrives steadily. Balance is maintained through time. If sleep begins to arrive now, that is perfectly natural. These ideas are not demands on attention. They are companions, drifting alongside you as the mind settles. Mountains will continue to rise and wear away long after this moment has passed. Rivers will continue to flow. Plates will continue to move. The planet will remain patient. And here, in this moment, there is nothing else required. Just rest. As the pace softens even more, attention begins to drift away from structure and process, settling instead on the feeling of continuity that mountains represent. By this point in the journey, the details no longer need to be held closely. What remains is a sense of steadiness, a quiet awareness of how the earth moves and adjusts without hurry. Mountains stand as reminders of duration. They show us what happens when time is given space to work. Nothing about their formation is rushed, and nothing about their presence demands urgency. They rise because conditions allow them to rise, and they change because change is part of balance. This understanding invites the mind to slow naturally. The land beneath us has always been moving. Long before the first mountain took shape, the earth was already shifting, already redistributing heat and material. Long after the highest peaks have softened into gentle hills, that movement will continue. Mountains are moments within that flow, not interruptions to it. When uplift begins, it does not announce itself. There is no sudden signal, no clear boundary between before and after. The ground lifts so gradually that life above continues uninterrupted. Trees grow, rivers flow, seasons come and go. The earth changes quietly beneath it all. In the same way, erosion works without urgency. Wind does not hurry. Water does not rush its purpose. Ice advances and retreats at its own pace. Each force acts steadily, contributing small changes that accumulate over time. This accumulation is what gives mountains their meaning. Not a single event, but countless moments of adjustment layered together. Pressure balanced by release, height shaped by wear, form guided by persistence. As mountains evolve, they influence the feeling of a place. High elevations create open spaces and wide views. Valleys offer shelter and calm. Plateaus stretch gently across the horizon. These forms affect how humans and animals move, how they settle, and how they rest. Throughout history, mountains have been places of pause. They slow travel, they alter routes, they encourage stillness simply by their presence. Even when viewed from afar, they suggest patience and endurance. That sense of patience is not something mountains impose. It is something they embody. They do not resist change, they allow it. They rise when forces lift them and soften when those forces ease. In doing so, they remain in balance with their surroundings, never separate from the systems that shape them. As erosion lowers peaks, new forms emerge. Rounded ridges replace sharp summits. Wide valleys open where narrow ones once existed. The landscape transitions smoothly without losing its coherence. Each phase prepares the way for the next. These transitions happen so slowly that they feel almost timeless. Yet they are always occurring. Even now, as this moment unfolds, the planet is adjusting itself in small, steady ways. There is comfort in this constancy. The earth does not demand attention to every detail. It does not require effort to understand its rhythms. Simply knowing that these processes exist can be enough to quiet the mind. Mountains form, change, and return to the earth whether we observe them or not. In this way, mountains free us from the need to control outcomes. They show that stability can arise from motion, and that balance does not require stillness. Change and calm are not opposites here, they coexist. As the journey continues, the emphasis turns inward. The long timescales of mountain formation gently reduce the weight of immediate concerns. Compared to millions of years, individual moments feel lighter, thoughts slow, attention softens. There is no need to stay focused on explanations or sequences. The patterns have already settled. What remains is the rhythm, slow, steady, unbroken. Mountains do not rush toward completion. They do not aim for perfection. They respond to what is present, adjusting gradually. This quiet adaptability is part of their strength. It can be grounding to recognize that the land itself follows such principles, that beneath complexity lies consistency, that beneath movement lies balance. As erosion continues its work, mountains release their material back into the wider world. Rivers carry sediment onward, soil forms, new landscapes take shape elsewhere. The influence of mountains extends far beyond their visible form, continuing even as they change. This generosity of process is subtle. Mountains give without intention. They participate in cycles simply by existing within them. Their role is not fixed, but evolving, shaped by interaction rather than design. The earth does not separate creation from release. Both occur together, guided by the same slow rhythm. As this section draws gently toward its end, there is no new concept to hold on to. Only a deepening sense of calm continuity, the understanding that the planet moves patiently, shaping itself through balance rather than force. Mountains rise, mountains soften, the earth remains whole, and within this steady motion, there is space to rest. As the movement of the story slows even more, attention settles into the simplest ideas beneath everything we have explored. Mountains no longer need to be understood as systems or processes. They can simply be allowed to exist as steady presences shaped by time and balance. At this point, the details naturally fade into the background. What remains is a sense of scale. Mountains remind us how slowly meaningful change occurs. They rise not through effort, but through persistence. They are shaped not by urgency, but by consistency. The earth does not hurry its work. Heat rises gradually. Plates shift patiently. Rock responds in its own time. Over millions of years, these small adjustments accumulate into forms that feel vast and enduring. This way of change feels calming to observe. Mountains do not resist the forces acting upon them. They yield, bend, and adjust. When pressure increases, they rise. When pressure eases, they soften. In this response, there is no struggle, only balance. As erosion lowers their height, mountains do not disappear. They transform. Their substance becomes soil. Their minerals feed rivers and plains. Their influence spreads outward, becoming part of landscapes far beyond the original range. In this sense, mountains are never lost. They are redistributed, their presence woven into new forms. The earth carries their memory forward, reshaping it into something different but connected. Time plays a quiet role in this transformation. Years pass without noticeable change. Generations come and go, yet beneath it all, the land continues to adjust. Even when the surface feels still, motion is present. This quiet motion is constant. It can be comforting to know that change does not always announce itself, that progress does not require speed. Mountains show that stability can be dynamic, built from countless small shifts that support one another. As elevation changes, so does perspective. High ground opens wide views. Low ground gathers and holds. Both are part of the same system, responding to gravity and balance. Neither is more important than the other. Mountains create space as much as they occupy it. Valleys form between ridges. Basins open beyond slopes. These spaces allow water to collect, soil to deepen, and life to flourish. The land shapes itself in ways that invite continuity. As rivers carry material away, they do not erase the mountain's influence. They extend it. Each grain of sediment carries a trace of its origin, becoming part of a broader pattern of movement and renewal. Over long spans of time, landscapes soften. Sharp edges become gentle curves. Contrasts diminish. The land settles into forms that feel calm and stable, even as change continues beneath the surface. This softening is not decay, it is completion. A return toward balance after uplift has done its work. Mountains are often associated with strength and permanence, yet their true nature is adaptability. They persist because they respond. They endure because they allow change rather than resist it. This understanding invites a quiet sense of trust. The earth has shaped itself successfully for billions of years without urgency. It continues to do so now, guided by the same principles. As the story of mountain formation winds down, there is no final conclusion to reach. There is only continuation. The processes we have explored are ongoing, unfolding beyond this moment and far into the future. The land will continue to rise where conditions allow. It will continue to wear down where balance shifts. New mountains will form. Old ones will soften. The cycle will repeat, always guided by time and consistency. At this stage, there is no need to follow the narrative closely. The ideas are meant to drift, not to be held firmly. Like the slow movement of the earth itself, they can pass through awareness without effort. Mountains become symbols of patience, of quiet strength, of change that arrives without noise. As this section comes to a close, the emphasis rests fully on calm continuity, on the understanding that the planet moves steadily, shaping itself without rush. And in that steady motion, there is room for rest. As everything settles further, the movement of the story becomes almost imperceptible. The ideas no longer build or expand. They simply rest where they are, like land that has reached a natural balance. By now, mountains no longer feel like distant objects to be understood. They feel familiar, quiet companions shaped by time, carrying the calm assurance that nothing needs to happen quickly. The earth has always known this pace. Long before mountains rose, the planet was already adjusting itself. Long after they soften and spread back into the land, that adjustment will continue. The rhythm never stops, but it also never rushes. Mountains exist within that rhythm, shaped by it rather than imposed upon it. They rise when conditions align. They settle when balance shifts. They endure because they respond. There is no tension in this process, only cooperation between forces that have learned to move together over immense spans of time. Heat, pressure, gravity, water, and ice each play their role, not competing, but complementing one another. As elevation slowly fades through erosion, there is no sense of loss. The mountain's presence simply changes form. What once stood high becomes part of valleys, plains, and distant shores. The material continues its journey, becoming soil, sediment, and stone once more. This quiet transformation reminds us that permanence is not required for significance. Mountains matter not because they last forever, but because they participate fully in the Earth's ongoing balance. Their influence reaches far beyond their visible shape. They guide water, shape climates, support ecosystems, and create spaces where life adapts and thrives. Even as they change, their role continues. Over time, landscapes soften, sharp contrasts ease. The land finds a gentle equilibrium. This softness does not signal weakness. It signals completion of a phase, a return toward harmony after uplift has done its work. The Earth is comfortable with this return. There is no urgency to preserve a single form. The planet does not cling to peaks or valleys. It allows change to occur naturally, guided by conditions rather than intention. In this way, mountains model a kind of quiet resilience. They do not resist change. They allow it, adjusting slowly while remaining connected to the systems around them. This perspective can feel grounding. It suggests that stability does not require control. That balance can arise through patience and adaptation rather than effort. As the mind rests with these ideas, details begin to fade. The story no longer needs to move forward. Everything essential has already settled into place. The Earth continues its motion beneath awareness. The land continues its adjustment. Time continues its steady flow. Nothing more is needed. As we approach the final moments of this journey, the tone becomes even softer. The landscape grows quieter. The emphasis shifts fully toward rest, letting the long rhythms of the planet carry attention gently away from thought. In the final section, we will allow everything to come to a peaceful close, not with an ending, but with a settling, a gentle release into stillness, guided by the same patience that shapes mountains themselves. For now, it is enough to remain here, suspended in calm continuity, where nothing presses forward and nothing pulls back. Just steady presence, just quiet balance, just rest unfolding naturally. Everything now settles into stillness. The movement of the Earth continues, but it no longer needs explanation. The processes we have explored have already done their quiet work. What remains is a sense of calm continuity, like land that has reached a natural resting point. Mountains no longer rise or fall in our attention. They simply exist as expressions of balance shaped by patience and time. their long journey feels complete, not because it has ended, but because it no longer asks for focus. The earth carries on beneath awareness. Heat moves slowly upward. Rock adjusts gently. Water continues its steady flow. Nothing here demands effort. Mountains remind us that change does not need to be loud to be meaningful. That strength can come from yielding rather than resisting. That form can emerge naturally when forces are allowed to work together over time. As mountains soften and return to the land, they do not lose their presence. They become part of something wider. Soil forms, rivers flow, new landscapes take shape. The influence continues even as the form changes. This is the quiet generosity of the earth. Everything participates. Nothing is separate, nothing is wasted. In this long rhythm, beginnings and endings blur. Uplift becomes erosion. Erosion becomes renewal. What once stood high spreads outward, supporting life in new ways. Balance is maintained through constant, gentle adjustment. There is comfort in knowing that the planet does not hurry toward outcomes. It responds only to what is present, adapting steadily without urgency. Mountains rise when conditions allow. They rest when balance returns. The same patience that shapes the land also shapes time itself. As this journey comes to a close, there is no need to hold on to any particular idea. The understanding has already settled. Like the land after long movement, the mind can soften now, easing into rest. If sleep has already arrived, that is perfectly fine. If it is still approaching, there is no need to wait for it. There is nothing left to follow, nothing left to do. The earth will continue its quiet motion. Mountains will continue their slow transformation. Time will continue to unfold, and you are free to rest within that steadiness. Thank you for sharing this gentle journey. Rest well and sleep peacefully.